Carpe DMVPN. Seize the data.
A VPC or VNet is the base layer of all network constructs in the cloud, and all other network objects exist within it. A VPC or VNet is a logical construct that serves as the default boundary for connectivity, and they have an IP supernet allocated. Within that VPC or VNet, the networking can be further carved into subnets, tied to specific availability zones, or not, as design dictates. This allows easier placement of resources in a deterministic way for high availability and redundancy. Cloud-native networking involves a logical cloud router which handles the connectivity at the network layer within that VPC. By default, it has a single route table associated with any subnets created, which has a single route entry for the entire CIDR block of the VPC or VNet itself. This ensures that host-to-host communication within that VPC or VNet works. If required, subnets can be configured with specific route tables to make different routing decisions than others. This could be necessary to prevent hosts in a certain subnet from accessing the internet, or to force traffic inspection from a certain subnet when communicating with others. How this works is by manually editing the route table and inserting routes to use along with modified next hop values pointing at a specific required service. This is basically object-oriented routing and is a manual process. For any subnet which requires different behavior than connectivity to everything, a custom route table must be created and attached to the subnet. Cloud-native network constructs can be used to facilitate the connectivity between resources. As an example, if there's a need to offer one-way internet connectivity to a host which needs updates but should not accept any incoming connections from the internet, something like a NAT gateway can be deployed for hosts in that subnet. The subnet route table will have a default route for the internet, and the next hop will be the NAT gateway object. The cloud provider handles all the connectivity details in that case, and there's no visibility on what's actually happening from that connectivity perspective. We simply trust that the cloud provider NAT gateway construct is performing the correct networking and allowing the host to connect to the internet by providing that NAT. If we want to allow hosts in a different VPC or VNet to talk, we have a couple of options. We can natively peer them together, which requires configuration changes and updating the route tables to add the CIDR block for the other VPC or VNet to route towards, along with the next hop of the peer object. Again, this is a cloud-native object that handles the details of connectivity and offers no visibility. Worse, the peer attachment is a static attachment with no transitive capabilities, and so it lacks the capability to scale. As more VPCs or VNets need to communicate, the peering becomes unwieldy and hits a hard limit. For very small regional deployments, cloud-native networking can work, but the main takeaway from the cloud-native approach to networking is that it's an entirely manual process, and you have almost no visibility on what's happening inside and outside of that VPC or VNet. Let's transition to looking at networking using Aviatrix. First of all, nothing we've talked about so far is different with Aviatrix in the picture. A VPC or VNet is still the same thing as our route tables, subnets, and cloud-native network constructs. All of these things are still applicable. Where Aviatrix starts to show its value without even deploying a single gateway is in its ability to orchestrate and build the VPC from scratch, along with subnets and route tables based on the type of traffic expected. If it will be a VPC or VNet full of hosts, the controller builds it using a supplied CIDR and automatically deploys private and public subnets for each availability zone in that region, along with a route table for public and private workloads. Users can deploy their workloads into that new VPC or VNet easily. If the intention is to deploy an Aviatrix transit gateway or add firewall capabilities, the controller automatically orchestrates those subnets and route tables as well. This is the basis for building the data plane. We start with a solid deployment of routing, and next we deploy the actual gateways. The controller deploys a routing instance that will actually forward packets and build a data plane across the deployment. Rather than using native peering, which we discussed as an option for cloud native, we actually use these gateways to peer the networks together. This allows us to get the visibility and control of the whole deployment. The controller handles deploying the gateway, setting up the data plane for us, as well as orchestrating that VPC or VNet route table to point at the Aviatrix gateways for routing instead of something like a VPC peer attachment or NAT gateway. Packets come from the end host in the isolated network into the gateway, where our gateway is sending data plane telemetry to our Copilot platform for visibility. At the same time, the gateway is advertising the routing for that VPC or VNet to the controller, and the controller is using that route intelligence to program the route tables of all the other gateways. This gives us much more granular control of paths and full visibility of that data plane end to end. The gateways stay connected from a control plane perspective to the controller for further route updates and configuration. This is also how the controller detects gateway failure. When gateways are deployed in a high availability pair, the controller is orchestrating the route tables for the networks that the gateway is servicing, load balancing traffic between them by modifying route tables to set that gateway or its HA peer as the next hop for routing that leaves the network. If one of those gateways were to fail, the controller can detect this and then fix the route tables to use the remaining gateway. Aviatrix takes care of the routing for us without having to handle it all manually. There's a lot more to this, including extra cloud connectivity options, but this is a high-level comparison of cloud-native routing to Aviatrix so you can get an idea of the benefits that Aviatrix provides.